Our goal for today is to recall the laws of exponents. Now, before we go into the examples that are going to help us guide through the different laws that exist, let's go over the basic definition. So what is x to the fifth power? Well, this basically means that you have 5x's, or you have x times x times x times x times x, because basically what this is this number right here, known as the exponent or power, tells us how many times we have the base times itself. So we have the base being times itself 5 times. So we have x times x times x times x times x. And you can also go backwards. So if you have 5x's being multiplied times each other, that is the same thing as saying you have x to the fifth power. Now let's go over number 1. So you have 4 squared times 4 to the fifth power. So first of all, what do you notice? Do they have the same base? Remember, the base is the big number. So in this case, they do have the same base, right? They both share the base of 4. So now, if you don't recall what the law is, you can go ahead and derive it by going ahead and expanding this. So it's going to be 4 times 4, and that's going to take care of this one. And then we have the other 4. The other 5 4s that we have here. So we have 4 to the fifth power. So it's going to be 1, 2, 3, 4, and 5. So therefore, this gives us a total of 7, right? So we have a total of 7 4. So 1, 2, 3, 4, 5, 6, 7. So we have 4 to the 7th power. So now, what is the rule when you have two terms when they share the same base? What do you do with the exponents? Well, you go ahead and add the exponents, right? Because we could have gotten this answer by just doing 4 to the second power times 4 to the fifth power. Well, this is the same thing as 4, 2 plus 5. Therefore, this is 4 to the seventh power. So this is another way that you could have done it. And this is actually the way that is the easiest. So you won't have to expand it, because what happens if you have an exponent, for example, of 105? You don't want to write 105 fours. It is easier to just add them up. Now let's go to number 2. Number 2, again, the easiest way to derive the law is to go ahead and expand it. So let's go ahead and do that. Let's make the 4 to the fifth power on top red. So we have 4, 1, 2, 3, 4, 5, right? Because the exponent is 5. In the bottom, we have 2 of them. So we have 1, and then we have 2. Now here, you have to use your knowledge of division. So what is 4 divided by 4? Well, 4 divided by 4 is basically 1, right? So these two pairs, you can call them in a way, you have 1 on top, 1 on the bottom. So that's 4 divided by 4, that's 1. 4 divided by 4 is 1. So all you have left is 3 fourths on top, which you can write as to the third power, and you have a 1 in the on the bottom. So 4 to the third power divided by 1, well, that's just 4 to the third power. Now again, how could we gotten this answer easier is by using the law, right? So what can you do with the 5 and the 2? When you're doing division, you go ahead and subtract, right? So the easier way would have been to do the following. So you have 4 to the fifth, and you have 4 to the second. Because they share the same base, you have 4, 5 minus 2. So you're subtracting when you have division, and your answer is going to be 3. Next one, you have 4 to the second power, and then to the fifth power. So again, if you don't know the rule, we can just go ahead and expand this. So basically, this is telling us that we have this inside, which is 4 squared. Let me put that in blue. 4 squared is our term. So we have to put that term a total of 5 times. So it's 4 squared times 4 squared times 4 squared times 4 squared times 4 squared, right? So we have 1, 2, 3, 4, 5. So we have it 5 times. Now you can go ahead and expand it if you want, But in this case, I'm not going to do that because I already know when they share the same base and you're multiplying them, you can use this rule, right? Which is you add them up. So how many 4s am I going to have in total? Well, in this case, you have 2 here, another 2 here, so that's 4, that's 6, that's 8, and that's 10. So you have 4 to the 10th power. Now, what is the law for this? What would you have to do with the two exponents? So how do you get 10 from 2 and 5? If you said multiplication, you are correct. So if you don't want to go over the expansion method, but you can, if you ever forget, you can just multiply them. So you have 4 to the 2nd power, and then this is being raised to the 5th power. Well, this is just the same thing as 4 2 times 5. Therefore, your answer is 10, or 4 to the 10th power, sorry. So now you have example number 4. We have 3 times 4 to the 2nd power. Now, yes, you could do 3 times 4 is 12, and then 12 to the 2nd power. But in this case, I want to demonstrate that there's a different way to do this. So the different method to do this is to go ahead and expand it. So you have 3 times 4, and then because it's to the 2nd power, that means that we have it twice, right? So we have the inside a total of 2 times. So this is 1, and then, oh, sorry about that. Ooh, where is my, oh, here. Okay, so here we have once, and then I wanted one more because remember it's 2, so it's going to be times 3 times 4, right? So now we have it twice. Sorry about that. And now we can go ahead and group them together. So how many 3's do I have? Well, we have 2 3's and then we have 2 4's. And remember, I can move them around because 3 times 3 is the same thing. 3 times 3 is 9, and then 4 times 4 is 16. 16 times 9 is the same thing as 9 times 16. It gives you the same answer. And we can write this in exponent form. So this is 3 squared and 4 squared. So basically what it's doing is you're using the exponent for both of the terms that you have on the inside. So the quicker method for this would be 3 times 4 to the 2nd power. This is the same thing as 3 to the 2nd power times 4 to the 2nd power. Because they do not have the same base, you cannot add these two together. So a common mistake that I see is students writing something like 12 to the 4th power. So they multiply the 3 and the 4, and then they add the exponents. That is totally false. That is not true because they do not have the same base. Now, number 5. So for number 5, again, what is one way to do it? You should know this by now. What we've been trying. Yes, it's expansion. So let's go ahead and use expansion. So expansion means that I have to go ahead and write the inside how many times? The exponent, right? 3 times because the exponent is 3. So we have, and I'm going to make this 3 over 4. Let's make it yellow. So 3 over 4. So we have it 3 times. So it's going to be 3 over 4, and then times 3 over 4, and then times 3 over 4. Well, in total, I have 3 3's and I have 4 3's. So it's 3 to the 3rd power and 4 to the 3rd power. Notice that we could have just used the base and the exponent when you have it to reach our solution faster. So if you want to do this faster, this would be 3 over 4 to the 3rd power. Well, this is the same thing as 3 to the 3rd power over 4 to the 3rd power. Now, the reason why I went over this is because this is actually one of your first topics that we're going to be covering from your calculus book. If you go to page 14 on your calculus book, which is linked on your Google Classroom, you will notice that you will find this table. Now the table goes ahead and summarizes what we just went over. So in the table, you'll notice that they have a base of 3. Now I decided to use a base of 4 to show you that it can be done with different numbers or different variables. So in the first one, we went ahead and did 4 to the second power times 4 to the fifth power, and we got 4 to the seventh power. Notice that they use 3, so because they have the same base, you add the exponents, so that's 3 to the seventh power. And then they went ahead and did number 2, 3, 4, and 5. Okay, this is it for the lesson. Bye, guys.